Good day everyone, we are Group 8 and today we'll be presenting about process states in operating systems. Our group is composed of 4 members. I am Aldrin Abaenza together with Reven Mi Efable, John Paul Sincabo, and Marvin Waben. Together, we'll guide you through how processes move through different states in an operating system and why these states are important. Now, let's begin with our first topic. What is process? Once again, good day everyone. Today we'll talk about process states in operating system. A process is basically a program that is alive. It's running, not just stored on the desk. To manage this, the operating system uses something called a process control block or PCB. The PCB is like a profile card. It keeps the process ID, its current state, and its progress so the OS knows exactly what's happening. To make it simple, think of programs as students and the operating system as the teacher. The teacher keeps order in the classroom, making sure every student gets a fair chance. In the same way, the OS makes sure each process gets its share of CPU, memory, and an input or output. So, in short, a process is a running program and the OS is the manager that keeps everything in order. Now let's talk about the process journey. Processes don't stay in one place. They move through different states during their lifetime. First is new. When the process is being created, then comes ready where it's prepared to run but waiting for CPU time. Next is running. When the process is actively using the CPU, sometimes it goes to waiting. If it needs input or resources, finally, it reaches terminated, which means the process has finished execution. To make it easier, think of it like a life cycle. Process is born in the new state, like an infant waiting in ready. It works as an adult in running, pauses like retirement in waiting, and finally ends in terminated, just like death. This journey shows how the operating system manages processes step by step. Let's look at the new and ready states of a process. In the new state, the process is just being created. Resources are being allocated, and it's like a student enrolling in class. At this point, the process is not yet running, but it's getting prepared. What happens next is the process moves to the ready state. Here, the process is already sitting in memory, waiting for CPU time to execute. The scheduler, which acts like the organizer, decides which process gets the spotlight next. You can think of this stage as the warm-up before the real action begins. The process is ready, just waiting for its turn to run.
Now, let's check out the running and waiting state. When a process is running, it's using the CPU right now. This is when it's actually doing the work, executing instruction. CPU time is a super valuable at this point. But sometimes, a process needs to wait for something. That waiting state is stuck waiting for input or data. Think of it being on hold in a call. You're not gone, just waiting for your turn to be helped. So process switch from running to waiting when they need something and back to the ready when they get it.
Hi, I'm Reven Mi Efable. Let's finish up with the terminated and advanced states. The The terminated state is when a process has done its job and exit. It's like a graduation, it's done, it's part. Then three are advanced states. Suspend ready means it's ready but set aside temporarily. Suspended waiting means it's awaiting and move out of memory. Cleaning important, it saves memory and keeps the system stable. That is for this state. Let's see where we go. How we go.
Hi, I am Marvin Lipuaben, and I tell you about your reference. We use your sources to make sure everything we explain is correct, reliable. We got materials from the Polytechnic University of the Philippines for your OS course. We also use the textbook operating system conceived by Selber, Sturt, Calvin, and Ginn. And for online stuff, we look at tutorial point and Geek- geeks for their articles of process state. Thanks for listening.